This is Alan, and I'm filming today from beautiful Brienz, Switzerland. So we're actually on a boat ride right now between Brienz and Interlaken. And so the topic of today's video is going to be understanding your quality improvement problem. So by the end of this video, what the aim is to be able to avoid one of the key problems, key pitfalls in quality improvement, which is going straight from problem straight to solution without truly understanding what the problem is. And so the drawback of doing that approach is that often you will come up with a solution that is tailored to either the wrong problem or addresses an insufficient number of factors. So I'm going to start with a clinical example of not truly understanding the problem you're trying to solve. So if you come across a patient on the ward who all of a sudden is short of breath, and you just, without even thinking about it, assume that that patient has heart failure and order Lasix, without really taking the time to do a history, a physical, investigations to figure out why they're short of breath, that patient might have, say for example, a pulmonary embolism, and the treatment that you prescribed is not only not helpful, but it's harmful. But that diagnostic step often gets forgotten in quality improvement projects. And again, even in big projects, sometimes you go straight from problem to solution without doing the due diligence of the diagnostic phase. And so the way to get around this issue is to be deliberate about hypothesis generation and hypothesis validation through a diagnostic phase. So there are several tools that are available in the quality improvement armamentarium to do this. And I'm going to go through a bit of a QI example right now, which is about a project that we did at a withdrawal management center.
And this is a personal example. So when I was finishing up my master's, I was doing a practicum at an organization which will be named, which will remain nameless. It was not LHSC. And the problem was that in the withdrawal management center, which is the detox center, they were experiencing volumes at less than 0.5% of the target. So that sounds like it might be good, but it's actually not, because they're mandated to see a certain number of individual patients per year by the government. And if they're demonstrating that they're only seeing half of that number, the government is perfectly within its right to take back half of their funding. So that's not good at all. When they described the problem initially, what they saw was this. So the way that their detox center is set up is that for the acute withdrawal phase, there's a high acuity 9-bed observation unit with a capacity for 6 men and 3 women, and the average stay through that acute detox phase is about 45 hours. And once they go through the acute detox phase, they go back into a larger area, which is a residence with beds, and they stay there for about a week, 30 beds there, and they undergo various group exercises, meetings, addiction counseling, and things of that nature, and they're there for about a week. So what they saw was that in the big area, the residence, it was really only half full. And they were noticing that observation appeared to be the bottleneck. So the immediate solution that they jumped to was we got to get people through observation faster so that we can get them to residence. So they were talking about, risk stratification so that maybe some people didn't need to stay for the full 45 hours, maybe increasing capacity with some extra chairs, tox screening, which would be just a form of risk stratification, so universal tox screens, things like that. So basically aimed at getting people through observation as fast as possible so that they could get through to the next stage. What we did was timed observations. The way this works is you list your process steps down the left-hand column. So in this case, the way a patient would be admitted to the detox center was they'd call in, they'd say, hey, I'm withdrawing, I want to come in and detox. The attendant would schedule an admission. We would then wait for them to arrive. They would be admitted. They would stay in the observation area and then eventually be admitted to the residence area. And that should say residence stay. And all the numbers you see at the top, 1, 2, 3, 4, 5, etc., are instances basically. So for patient number 1, you would write how much time they took, or the time that scheduling was done, then the time that they arrived, time that their admission was completed. So you basically want to see how long each step in the process takes, and then do that for 12 patients. See how much time the task took in total, and then your observations are written on the side there. That way you capture the narrative as well. So if someone's admission took super long because, say for example, they had to, go and pick up some lorazepam for their withdrawal or something like that, and they didn't have it on them, just an example, then that's a remark that you could put in to that column. So when we did this observation, what we were actually seeing was that observation was not full. So at any given time, if you looked into the bed situation, this is what we're seeing. Red represents a full bed. So even though the observation area was described as being quote unquote full most of the time, in actuality, it was less than half full. This is really what it should have looked like if the withdrawal management center was on track to meet its obligation to the ministry. So now we can use a 5Y. We'll use the 5 Ys to figure out why, what the root cause is for the empty bed situation. So why are they persistently empty? They're being reserved for clients who are late or just straight up no-shows. So why are we reserving? Why are we not just taking clients on a first come, first served basis, just kind of show up? The reason is because we need to space out admissions more predictably. The reason for that is because one attendant could not process multiple admissions. It was too much work. And why is that? Is because the admissions process is very inefficient, with a lot of duplication of paperwork, a lot of questionable practices or practices of questionable value. So admissions were taking half hour to an hour. So you can't handle the volume of people who are just showing up randomly. So the ultimate solution is not to create more capacity in the observation unit. It's not to risk stratify. It's to streamline the paperwork during the admissions process so that you don't have to reserve beds. People would be able to just show up on a first come, first served basis. A very different solution than the ones initially proposed.
So that example shows what can happen if you don't truly understand your quality improvement problem. So the solution to this, as I previously mentioned, is to be deliberate about your hypothesis generation phase using some of those tools that we just went over. So classic tool is an Ishikawa diagram or a fishbone. Another tool that you can use is the 5 Ys. We use a process map in the Withdrawal Management Center project, and direct observation as well. So you can also use tools from conventional research, which can include a literature search, and of course just talking to the people at the front line to get their opinion on what the problem really is. The bottom line though is that unless you have a distinct hypothesis generation phase coupled with a hypothesis validation phase in order to truly understand what the underlying problem is, you may not be getting to the root cause that's leading to your poor performance, and you might be solving the wrong problem. So before you embark on a solution generating phase, make sure that you're solving the right problem. Take the time to generate hypotheses, take the time to validate your hypotheses with quantitative measurements, and you can guarantee, or at least increase your chances of solving the correct problem. So I'll be signing off for now. Until the next video. This is Alan. Peace.
That's good stuff. This potato fondue. Cheesy goodness.